Ignition sequence starts.
Good morning and welcome to Mission Control Houston and the International Space Station Flight Control Room. This is where there's always a team of specialists on duty to monitor the systems of the station and work with the Expedition 60 crew members as they take care of their home on orbit and assist researchers with their science in space. Space Station crew members also assist with the comings and goings of visiting vehicles like the Dragon cargo ship that arrived on orbit late last week and the Progress supply freighter that automatically docked to the station's Russian segment this past Wednesday.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Gary Jordan. More cargo made its way in the fast lane to the International Space Station. The Russian Progress vehicle launched from the Baikonur Cosmodrome on Wednesday. It took only 2 orbits around the Earth to meet up with the orbiting laboratory for an automated rendezvous a little more than 3 hours after liftoff. On board, nearly 3 tons of cargo, including fuel, water, and spare parts. With the successful capture and berthing of the SpaceX Dragon last weekend, the crew wasted no time getting right to the science on board. Space Station residents configured the biofabrication facility for a test this week. This facility will test techniques for printing 3D biological structures that could help with eventually manufacturing usable human organs in space. Small, complex parts of the human organs, like capillary structures, may be more successful to manufacture in microgravity. Even with a busy week of cargo and science, the station crew took some time to share their perspective from 250 miles above the Earth. Nick Hague and Luca Parmitano spoke with the Weather Channel this week and shared some thoughts from the orbiting laboratory.
We are involved in all kinds of events where we can try to help with our positioning and our quick downloading of the pictures. A couple of years ago, when there was a terrible fire in California, we were actually able to document in real time where the fire line and where it was moving, and those pictures were downloaded as fast as possible, sent to the California firefighters in order to give them a chance to react more quickly.
You know, this is my first flight, and so looking out the window, this was the first time I got to see weather at a global scale. Probably the most striking thing that hit me the first time was watching a thunderstorm at night coming up over the west coast of the United States and seeing the lightning flashes just blanket the entire United States as far as you could see, and it seems like they were always going off somewhere, and just the scale of that was just mind-blowing.
Keep sending us your questions using the hashtag AskNASA. We'll see you next week.
Gary mentioned the biofabrication facility. That's a cutting-edge piece of hardware now being tested on the International Space Station. Researchers are looking into using 3D printing technology to manufacture biological materials in microgravity. It could allow cell growth in 3 dimensions and potentially could get around the problem of immune system rejection of donor tissue if a patient's own cells are used to grow the new organ.
Cutting-edge biomanufacturing aboard the International Space Station.
presented by Science at NASA. Most likely, you're aware of 3D printing, which allows you to design and produce one-of-a-kind pieces for a variety of purposes. But what if you could use that same technology to manufacture biological materials, like new tissue or blood vessels? Welcome to the world of 3D biomanufacturing, a cutting-edge practice on Earth that is being tested aboard the International Space Station, or ISS. Dr. Mike Roberts, Deputy Chief Scientist at the ISS U.S. National Laboratory, explains why the space station is critical to biomanufacturing's future. We've been able to grow cells in a lab for well over a century, but gravity limits that growth to 2 dimensions. Cells can grow outward, but not up and down like they do in the human body. Also, lab cells are often in contact with the glass or plastic that contains them. But aboard the space station, our experiments will be conducted in microgravity. That allows you to build your cell models in 3 dimensions, without being confined to the bottom of a dish, or unable to grow in contact with lots of other cells. Biomanufacturing imagines the ability to someday grow a viable human organ. Organs are composed of specific tissue intersected by blood vessels. Most organs and thicker tissues in the body have a rich, complex network of blood vessels that provide nutrients and remove wastes from the living cells that make up the tissue. We currently lack the ability and the tools to engineer these highly branched, living networks of vessels inside layers of tissues on Earth. Another medical advantage to manufacturing biological parts in space is the potential to bypass the body's immune system. Today, organ transplants from donors are prone to rejection because the patient's body perceives the new organ as a foreign object, and their immune system tries to attack it. But with the ability to grow tissue in space, a person could conceivably have their own cells used to make their new organ, which might avoid the body's rejection. 3 different types of biomanufacturing facilities will be tested aboard the space station. 2 of them perform in a manner similar to a standard 3D printer. They extrude cells in layers to build tissue. The 3rd type uses powerful magnets to position the cells in place. Each of these 3 different approaches to bioprinting in microgravity will be available to medical researchers seeking to better understand how to engineer tissues and organs for use in repairing injury and curing disease on Earth. As Dr. Roberts notes, the 3D bioprinters represent cutting-edge technologies that could clearly benefit health outcomes on Earth. I think the ability to manufacture a fully functioning human organ will take some time, maybe a decade or more, but the knowledge we'll acquire to get there will also create interim benefits as we learn more about cell regeneration in space and its application to humans on Earth. For more inside information about studies inside the station, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.
International Space Station science research covers a range of scientific disciplines. One of the priorities is to learn as much as possible about how the human body is affected by living in space. Shortly before she came home in June, flight engineer Anne McLean and her crewmates wrapped up the data gathering on the Airway Monitoring experiment. It examines an astronaut's exhaled breath for signs of inflammation. It's part of the process of designing future spaceships to be safer for their human crew members to use on long-duration missions.
The International Space Station is a national orbiting laboratory. Every single day we are answering big questions about Earth and about space, about where we came from and about where we're going. One category of those experiments are human research, experiments on our human body, how we react in microgravity. One of the recent ones that I've been a part of is called Airway Monitoring, and this is looking at airway inflammation up in space. So when we're breathing the air, you know, the small particles in the air, they don't just fall to the ground like dust on the ground. So we tend to inhale more fine particles than we would on Earth. And so we're looking at our response, our body's response to that by measuring nitric oxide exhalations as an indicator for airway inflammation. And so understanding, you know, how clean does our air need to be? How does our body react to the air? when we talk about going back to the moon, a lot of people are aware that the moon dust is a very, very fine particle. It's almost like a powdered sugar fine particle. And if that's in the air and we're breathing that for months on end, if we're doing, extended stays on the lunar surface, we need to understand kind of how that affects the human body.
The microgravity in Earth orbit makes the International Space Station a one-of-a-kind spot for scientists who want to find out how natural forces function without the influence of gravity. In this Speedy Time segment, astronaut Jack Fisher uses a few simple tools to demonstrate how water behaves when there's no pull of gravity.
Today we're going to look at one of the coolest parts of having experiments on the space station. It's because we can separate one of the most dominant forces, gravity, on a lot of different models. A great example is water. Water is pretty much dominated by gravity on Earth, but there's other forces at work that if we understand better, we can have a better model and make greater discoveries. Things like surface tension, capillary action. I'm going to show you today by taking this wonderful bottle, repurposed from a condiment, and blowing into it. When I displace the fluid with air, it will come up the straw and cover my face.
Science in the laboratory, just a part of the mission of the International Space Station. It also encourages the commercialization of spaceflight and space research and international cooperation, and helps prepare us for the next steps in space exploration, including the Artemis program and a return to the moon by 2024. Teams across America and in Europe that are part of NASA's Orion, Space Launch System, and Exploration Ground Systems programs are developing the spacecraft, rocket, and ground systems needed to send human beings to their next destination beyond Earth orbit. you've got to know about a lot of different subjects to graduate from West Point, and then to become a doctor, and then to become an astronaut, when you have to know some of it in Russian. But can you think fast on your feet? Well, NASA astronaut Drew Morgan had fun with a rapid-fire Q&A on non-technical topics as he finished up preparations to launch to the International Space Station.
Clock has started. Roger.
What's your favorite movie?
Band of Brothers.
Your favorite food?
Anything spicy.
Favorite color?
Olive drab.
Are you a morning person or a night person?
Definitely a morning person. I'm not demonstrating that very well now, but yes, I am a morning person.
What's your favorite ice cream flavor?
Mint chocolate chip.
Is there one thing you have in your fridge all the time?
Milk.
What accomplishment are you most proud of?
My kids.
Who's the person that makes you laugh the most?
My wife.
What's your most memorable career moment?
Graduating from Ranger School and being promoted to Major on the same day.
If you could have one superpower only, what would it be?
Time travel.
What's your favorite pizza topping?
Lots and lots of cheese.
Your favorite animal?
Armadillo.
Favorite dance move?
Air guitar.
Who inspires you?
My dad.
What would you like to be remembered for?
Being a good husband and father.
What advice would you give to your younger self?
Be a good team player.
What would be a good theme song for your life?
Live It Well by Switchfoot.
If you could spend one day on Mars, what would you do there for fun?
Take pictures.
What is a life goal you plan to achieve this year?
Come home safely from space.
Now, flight engineer Christina Cook is almost 5 months into her mission, which is scheduled to stretch into February of next year. She says the concentration and control that she learned in one of her favorite pastimes, mountain climbing, helped her prepare to be an astronaut and to make the climb to space on her first mission to the International Space Station.
I first got involved in rock climbing actually in college. My college, North Carolina State University, offered rock climbing as a PE class. So it sounded really exciting, maybe a way to kind of get outside and have a little adventure. When I first got started, I liked more the physical challenge. That's what it was about. And as I kind of advanced in the hobby and got more technical, I found that I really liked other aspects of it, like the equipment, the gear, the physics of the system that you have to use, and also the partnership aspect of it. It's really like a team, because when you get into some of the higher levels of climbing and different types of more technical climbing, you really rely on your climbing partner. We train for spacewalks in a giant pool that's called the NBL, which stands for Neutral Buoyancy Lab. And it's a pool that's large enough to fit a full-scale mock-up of the International Space Station. So in that, we simulate everything like we would on a real EVA, including egressing out of the airlock, your safety tethers, and your local tethers that you would work when you're at a work site performing the job. So all of that is just very similar to the concepts of rock climbing. So during my astronaut interview, the most memorable question that I had from the interview committee came from Peggy Whitson, who, as you know, is a famous astronaut for having the longest time in space. She's done many, many spacewalks. She's a hero of mine. And she looked at me and she said, "When you rock climb, have you ever been scared?" And I felt like she was seeing right to my soul when she asked that question. And I feel like the answer to that question was absolutely, I have been scared. And that's when I really kind of found the fact that turning that fear that you might be having into focus is so important. And I think that's what she was drawing on when she asked that question. So that was a pretty profound moment in my selection process. I'm Christina Cook, and I'm an astronaut.
The astronauts and cosmonauts on the International Space Station spend their time helping with scientific research, as well as maintaining the station to be their home and office on orbit. Sometimes they do spacewalks, and sometimes they're able to show us a little of the behind the scenes of the spacewalk. In this demonstration video, astronaut Ricky Arnold starts with the training astronauts get on the ground to be ready to walk in space.
Welcome to the Quest airlock on the International Space Station. I'm Ricky Arnold, Expedition 56 flight engineer from NASA. Today we're going to talk about one of my favorite topics, extravehicular activity, or EVA. Going out on an EVA or a spacewalk has been one of the most amazing experiences of my life. But it's also one of the most complicated and dangerous things we do during human spaceflight. There's a lot of equipment to prepare and maintain, and we do months of training to make each EVA a success. If you think it sounds complicated, you should see all of it in action. Let's start with training and how we get ready for a spacewalk.
Space is an extreme environment that presents many hazards. If we're going to go outside the safety of the ISS, we have to be prepared. That's why EVAs are designed with safety as the utmost priority. We astronauts spend a lot of time in the classroom, just like you are now, learning about the hardware we'll be using and the specific parts of the space station we'll be working on. Then we get to go spend a lot of time training in NASA's giant pool, called the Neutral Buoyancy Lab, or NBL. Since it's impossible to simulate microgravity on Earth, the next best option is water. 6.2 million gallons of it. The NBL is 40 feet deep, 202 feet in length, and 102 feet in width. A lot of room to have a full-scale working model of the ISS, which we need for practicing our EVA maneuvers and assigned tasks. We get suited up and weighted so that we're neutrally buoyant in the water, so we don't sink to the bottom and we don't float to the surface. It's a great way to simulate the microgravity we'll be experiencing. We do several dress rehearsals of the EVA before we launch. This gives us the opportunity to prepare for any anomalies that may occur. We spend at least 5 hours practicing in the NBL for every 1 hour planned for the spacewalk. So we are very well prepared to execute the EVAs once we are in orbit. Once we are up in orbit, the EVA preparation continues. First, we must perform a pre-breathe protocol to displace the nitrogen in our tissues and help prevent a condition called decompression sickness. During pre-breathe, we breathe 100% pure oxygen and do some light exercise to help purge the nitrogen from our bodies. During pre-breathe, we will also don our extravehicular mobility unit, or EMU. This is a fancy name for a spacesuit. The spacesuit is basically its own spacecraft, shaped like a human. There is usually a red stripe on the leg of one astronaut, but not the other, so the ground can tell who is who. To ensure our safety at all times, we are always aware of our safety tethers and where we are in relation to our spacewalking buddy.
Hey, buddy.
There's a fellow crew member called the IV, the intervehicular crew, on the inside of the airlock, watching and communicating with us as the EVA progresses. We are also prepared for several contingencies should they occur. First, we are trained on the use of a jetpack that can be used to maneuver in the event of an emergency rescue. It's called a SAFER, or Simplified Aid for EVA Rescue. The view during an EVA is magnificent. It's beautiful out there. It's also extremely dangerous, but our months of preparation and all of those dedicated people working on the ground, working around the clock, ensure we are safe as possible when we work outside the ISS. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
This demonstrations are part of the International Space Station's education mission, which includes opportunities for students on Earth, from elementary school right up through postgrads, to talk to the crew members while they're in space. Station has a live television capability as well as an amateur radio setup for those events. In 2017, flight engineer Joe Acaba made an historic contact with the Maria Montessori Institute Educational Unit in San Cristobal, Venezuela. It was the first ever educational ham radio contact in the country's history, courtesy of the Amateur Radio on International Space Station program. Here's a look at the excitement on the ground as more than a dozen elementary and middle school students got their chance to talk to a man in space.
Latinoamericana con el fin de que el contacto pueda ser hecho en español.
Para nosotros poder establecer la comunicación debemos ver a la estación espacial y ella debe vernos, o nuestras antenas se deben ver. Entonces tenemos que superar las montañas que nos rodean.
¿Por qué? Porque indudablemente si hubiera sido en inglés, pues también tiene un impacto, pero no es el mismo impacto que se llevan los muchachos. Golfo Bravo Kilo, can you hear me? Yankee 2, Charlie Mike Romeo, November Alpha 1, Sierra Muchísimas gracias y bienvenidos a todos a la Estación Espacial Internacional y estoy listo para la primera pregunta. Over.
Now, we don't all get a chance to talk to the astronauts on board the International Space Station, but most of the world does get a chance to watch them fly overhead. Flight engineer Nick Hague explains how you can use the website spotthestation.nasa.gov to find out when and where the station will be visible to anybody standing in your backyard.
Did you know that we're traveling at 5 miles a second? We're going around the Earth so fast that we orbit it every 90 minutes. That means on the space station we see 16 sunrises and sunsets each day. Every one is magical to watch. But more important than the view, we depend on the sun's light to power our space station, and we use massive solar arrays to soak it up. Those arrays are so large that when the sun's light glints off them, it's possible to see us from the ground. That means you can look up in the sky at dawn or dusk and see our spaceship flying overhead. So take a few minutes to step outside, spot the station, wave hello to us, and remember what we represent. People from across the globe committed to working together to improve life for everyone on Earth.
spotthestation.nasa.gov. Well, if you want to get another look at any of the stories that we featured today, check us out online on YouTube and on Facebook. There are the whole addresses right there in the blue box. And while you're out there, take a look around, because there's a lot of other cool stuff you'll find about NASA and America's human spaceflight program. And while you're out there on the internet, check out Houston We Have a Podcast. Folks here at NASA talking about their work in all aspects of space exploration. We post new episodes every Friday. Today, Gary Jordan talks with International Space Station Commercial Space Utilization Manager Mike Reed about the current effort to open up more commercial opportunities on the station, including opportunities for space tourism and private astronauts. Go to nasa.gov/podcasts for today's episode. In fact, all of our old episodes are there too. The whole full library of all the NASA podcasts is there, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.